Greetings, welcome to my kitchen. My name is Meyer and I am here on the internet with you tonight to talk about tops a bit and how you might help your students or children to investigate the really cool science of tops. Tops are fun, but they are also a lot of deep science. Centrifugal force, centripetal force, angular momentum, friction, torque, kinetic and potential energy, conservation energy. Really fascinating stuff. One was fascinating enough, several of those things are fascinating enough, for my understanding was Niels Bohr, a famous physicist from the 20th century, was fascinated with this top. You'll notice it's orange on the bottom and green on top. If I spin it on the table, we can see if we can get to do something interesting. Don't know if people noticed, I'll try to spin it again. Okay, I think we found a way to control the spin here a little bit. We needed to get it, was a little out of control. And see if we can get it to behave and do what it likes to do. There, did it there for a second. We'll do it again because I think I can get better success. You see that it likes to turn itself over. Somehow, the deep physics in that allow this thing to turn itself upside down and keep spinning. Investigating tops with your students or your children can be relatively easy. You don't have to get into those deep science concepts. It should be on their level and getting them to drive the conversation and you ask questions critically. To do it, I would suggest some materials like these. I have a variety of top platforms. I'm calling this part of the top of the platform. And then a variety of spindles, the part that you spin and connects with the table. I have skewer tips. I have golf pencil. I have a couple of dowels of different diameters, and they have a little bit of a point on the end. I would have multiples of those because it does allow students to change one variable time, just as I would have multiples of the platform types. I also have different platform shapes too, so students could investigate whether the shape has an influence or not. One of the other things you'll want to have on hand is weights. I use pennies often and some tape to do that. Tape's also very useful for platforms that keep on sliding down the pencil or down the spindle. The other things I'd want to have on hand are a ruler and a stopwatch. Your cell phone stopwatch will work great. It does allow students to make some measurements. How far up is this? How far out from the center are those weights? Those kinds of things. In science, we do want to measure something. We need to use those mathematics to compare things. So if we're comparing two tops, we can know which one spins longer if we've timed it. And that's very important because making those comparisons is at the heart of science and changing a variable at a time. Discuss those variables, the things you can change. You can change the location of the weights, how much weight, those kinds of things can allow students to dig deeper into what's going on with that spinning, that rotational momentum. You can also use a variety of materials you just find around the house. The paper is nice because you can get those close to the same weight and size. But I also have some lids from containers. I also did the hard work of collecting some six-pack holders. Those also can be useful. Here's one of those cut apart with a hole drilled in it for the dowel size. So those can be helpful as well. Let's see. As the students are investigating things, it's also helpful if you can connect it to something in their understanding already, or something they've seen. They may have ridden on an amusement park ride or something at the playground that spins, and they can feel that outward pull on themselves. They may have noticed that a car that drives through the mud, later on when it goes down the road, it throws chunks of mud off of it. Right? That's the force of those things being pulled and released, friction holding them on there until they're released. Connecting with things like that really help kids in a lot of ways. It helps all of us to connect to our prior knowledge. If they wanted to investigate a top like this, they could, I have pennies on mine, I could spin it and measure, and that one showed the need for tape. My friction is failing on the pencil, so I'll add another piece of tape on there to add a little bit more friction so the platform spins with the pencil, not independently of it. Of course, there's always trial and error at experiments and getting your experiments sorted out. Helping kids work through those kinds of frustrations is important. I think that's a little high. I'm going to try a lower. My experiments suggest lower down helps. And that's too low. Sometimes the materials can be frustrating, and that's an important thing to work through that, but also to realize that depending on the nature of your investigation with a kid, you could use more permanent or sturdy materials than this. This is just inexpensive. There we go, that's a better spin. You can also make tops from things you find around. This is a CD with a marble glued on the bottom and a cork up top. This one's particularly helpful for younger children, as they won't have the dexterity to handle the skinnier ones. I've also made some tops out of nuts. Around Christmas time in the supermarket, you can buy individual nuts. Here's a walnut with a skewer through it. Here is an almond with a piece of a skewer through it. I did drill those out in advance before sticking them in there and adding some glue. Here's a hazelnut. And finally a acorn with a toothpick through it. It's actually one of my favorite spinners. You can get into the effects of our persistence of vision with humans with tops. If I spin this one, sometimes people can see colors in there. This is also referred to as Benham's disc. It's an illusion, scientific illusion. Here's another one that gets you hypnotized and makes you say, I love science, I love science. With older students, I've made tops using a woodworking class in a lathe. So you can work with kids of different ages to work at different projects that are an entry level into that sort of concept. There's the art and science of those things together. One more thing I wanted to show you requires a quick break to allow me to set up one more thing. Developing an understanding of tops and working on our critical thinking skills and how we understand something through evidence and through actions to test our understanding is not just limited to tops and this planet. We also see those kinds of things with our efforts to get off this planet and understand our universe. And some of that may be through looking at the solar system. Some of it may be traveling in it. I have a wheel spinning. Now we see that the wheel didn't want to lay flat as we would sort of expect when I let it go, but it is spinning around my kitchen light. And you can see some interesting effects to it. We see this with planetary rotations and planetary movements through the atmosphere, through the sky, through the solar system. And we also see it through comets as they enter our solar system and get affected by the mass of the sun. So kids who play with tops today and learn about them can be the scientists of tomorrow and engineers of tomorrow who get us places and develop new understandings of the world in which we live. Thanks for your attention tonight, and hope you have fun playing with tops.